Alright everybody, in case you did not watch the opening intro video or did not write those definitions down, I'm going to encourage you to pause the video and take a moment to write down those 3 definitions for A, B, and C. We've been working with them on the front and also last week, but it is important that you have them written down so you can refer to them, especially for what we're about to do. A is the distance from center to vertex, B is the distance from center to covertex, and C is the distance from center to focus. Alright, again I paused that video. For some reason it seems to keep recording, so I apologize for that 1 minute lag. We are going to look at our examples now for writing an equation. When we go to write an equation, we're going to need to use those definitions to help us kind of figure out what A and B are, as well as where the center is. So I'm going to always encourage a little sketch, and literally a sketch, meaning I don't use graph paper, but just to give myself an idea. So I'm going to make something where I can see where negative 3, 0 is, and where 3, 0 is, and then 0, negative 2, and positive 2. And hopefully, with just a little sketch, nothing fancy, I can kind of see that this is a horizontal ellipse. The other thing I might be able to tell pretty quickly is that my center of that ellipse is halfway between negative 3 and positive 3. So if I think about negative 3 and positive 3 and what's in their center, I would argue that since they're opposites, I can see that that center is at 0 for the x-coordinate. It's also going to be 0 for the y-coordinate. So that makes my center at 0, 0, which means the first part of my ellipse is fairly easy to write because there's no movement away, and so I can just start with that centered portion. Now beneath these values, I'm going to need either an a squared or a b squared, depending on which way the ellipse is oriented. So since I can see from my little sketch that it's horizontal, I know that the larger number is going to be underneath the x. And so again, if I count from center to vertex, 1, 2, 3, I can square that 3 and put it underneath. And I can count from center to covertex, that's a count of 2, and 2 squared is 4. And the value for C, distance from center to focus, does not apply in this problem because there's no reference to the focus, nor am I initially, when writing the equation, required to do so. It does say to find the foci of the ellipse though, so we will do that kind of off to the side as an addendum. So we're going to do c squared is a squared minus b squared. So our 9 minus 4 lets my c be plus or minus root 5. And I still have to use that root 5 in conjunction with my center. So keep in mind this is with a horizontal ellipse, which means it's going to move away from the center. So we never specifically wrote down the center of 0, 0, but we certainly can kind of put that off to the side if we'd like. And so we're going to move from our x-coordinate root 5. So that means I'm going to have root 5, 0, and negative root 5, 0 as my foci. And just to make sure that that's clear, I might kind of put them all together and make sure that they're grouped accordingly. And there's both your equation and the foci.